Okay, Caitlin has a couple of questions about how we do sizeof, so let me go over to our class code and make a sizeof directory. Sizeof. Okay, I'm sorry. The class has questions.
Yeah.
I don't have questions.
Who doesn't have any questions?
Why are you in that and not in GVim?
Oh, you're right. All right, GVim.
You should know better. We can't see it on there.
Yeah, that was like black with some purple and some red. Whoa.
Unless you change your color scheme, and then we can see it all.
Int main, int argc, char star argv.
You're actually warmer than me too. I'm like, man.
All right. So if we're in here, I'm going to do std cout. But it's so funny.
Because I like put them on her arm and I'm like, wow, you're actually warmer than me, but I feel like my hands are sweaty, so I was like, don't clammy, and then I just I was like,
All right, so we can do size of character, size of short. Literally, you can type in whatever you want here, and I'll tell you the size of it. We can also do long.
What about class?
All right, we'll get to that in a moment.
Okay.
I want to do this. So character, short, int, long. All right, G++, size of, and let's run the program. Characters 1, shorts 2, int is 4, long is 8. Warning, that is not always the case.
Only sometimes.
Why? On the 16-bit machine, int would be 2 bytes.
Why?
Because there's only 16 bits.
Because there's only 16 bits.
Where are my hands sweaty if they're cold?
But
So is
for
it
the
always-
purpose of the project,
Is it always like a proportion of the amount of bits, or is there like a cap? Like
Okay.
if I had 1,000.
There are definitions of what number should come up on which machines.
okay.
It's not exactly straightforward, but basically a character should always be 1. A short should be 2, unless you're on an 8-bit machine. I think. Then it might be 1. I don't know for sure. For
But
int,
you know the dimensions
but for
of
int, I told you, yeah, what I told you is correct. For long on a 32-bit machine, it was only 4 bytes. But we're on 64-bit machine, so it's now 8 bytes. All right.
So
Now.
you know how yours works, so you would know what the number should be.
Right, because I'm going to compile your code on my machine.
Yeah.
So as long as you use the size of, since I'm using my machine, it'll come out correctly.
Okay.
Why are we talking about this?
Because for project 1, you're supposed to calculate the amount of memory that your program takes up.
Yeah, we didn't know how to do that. And
All right.
Google is no help for this.
Also, very important, if you have a pointer to a long, how much memory do you think that'll take up?
4.
1.
Depends on the bitness of your machine. Since these are 64-bit machines, a pointer takes 64 bits, which is 8 bytes. If we were on a 32-bit machine, that number would be 4. If we were on a 16-bit machine, that number would be 2.
Okay.
All right. Now, hold on. Whoa, whoa, whoa. How about the size of a pointer to an integer? All right.
Would it be the same thing?
4.
We have same thing for anyone else.
That'd be the same thing. It's a pointer like the other one.
I thought a pointer was supposed to take up less space.
So it's still 8
I mean,
because a pointer has to be able to point to anything in memory. If you're on a 64-bit machine, it needs to point to anything in that 64-bit address, which is
any of them.
right.
Then
Which is,
why denote it as like a pointer to an integer?
because then you can have type safety. Because then if you try and dereference it, the compiler will say this has to be an integer. And if you try and cast it to something else, the compiler will at least stop you unless you decide to manually cast it. Just to bring this home, let me go ahead and do a short pointer.
Oh my gosh,
A pointer to a short, and a pointer to a character. Just to bring it home that they're all 8 bytes, even though a character only stores 1 byte.
So, but if you know, I mean, if you're gonna know what kind of pointer it is, then why not make it right size?
Remember, the pointer stores a memory address. So it's the size of what it takes to store a memory address, which is 8 bytes on this machine. And to really bring this home, we'll have a void pointer. How many bytes do you think this takes up?
8.
Yep. In other words, it's irrelevant what it is actually pointing to when you're calculating the size. When you're calculating the size, it's irrelevant what you're pointing to if it's a pointer, because a pointer always takes up the same amount of space.
What type of size of is actually which one?
So size of is a built-in function of C. It is part of the C specification. And I don't know if I get the manual page. We do not. But if I recall correctly, it returns a size underscore T, which is either an int or a log, depending on your implementation.
So if I wanted to like do like let's say like a basic multiplication operation on it, I will have to cast the size.
So it's an integer. If it'll automatically cast it to a log if you need to, or vice versa. The compiler is going to tell you if there's any problems. But it's whatever size of T is defined as, which I don't recall off the top of my head, but it's probably an int, possibly a log.
Okay, so you shouldn't have any operation issues when.
You should not, no. It should be able to do all that for you. All right, so now if we have a class, dragon, private, let's give the dragon
10 hit points.
int, all right,
Over 9,000.
Yeah, actually, I agree with that. 9,000.
HP. We're just going to give it some HP.
Okay.
And then we do a size of the dragon.
Whoa.
M stands for member.
Yeah, remember, when I use it.
Okay.
That's just a coding convention I have. So you can do size of dragon. Whoops. It's currently 4. Why is the size of dragon 4? It has an integer. So if we had, you know, MP, and what would be another M level
TV?
trade points.
Should have been nano.
No, I think it's
Are we in Yu-Gi-Oh?
I don't know what this stands for.
So it's 16. Why is it 16?
4 plus 4 plus 4 plus 4.
16.
All right.
Yeah.
If we decide to make the name be a character pointer, how much should it be now?
17. Or, yeah, 17. Right?
A pointer,
Pointer.
24.
Okay.
24, because it's a pointer.
I didn't see that it was a pointer.
Oh, I'm sorry. It's okay.
It's pretty far back here, you know?
Yeah, I understand. So if I got rid of that, what should it be?
17.
Ah! 20!
What?
All right. All right. This is where things are going to get weird.
That's me.
Whoa, whoa, hold on.
You did that on purpose.
No, no, no.
This is evil.
17 was a correct answer. 20 is also a correct answer.
What?
I'm going to now things are about ready to get really weird.
They were
Whoa.
already.
Weird.
What should it be now?
Dragons don't have last
24.
names.
It's still 20.
What?
Wait, what?
All right, here we go.
Dragons don't have last names.
I'm just
Don't.
What about of?
They have nicknames.
Or names.
Full name.
Are you better?
Yes.
Okay. All right.
They have last names.
For all you know, dragons aren't even real. You don't know.
This is a little beyond the scope of the class, but that's perfectly fine. I don't mind going through it.
You didn't mark it. Or don't, that's okay.
Oh.
Throwing things out.
Calm down.
You think you're
There's
upset?
no reason to get that mad.
We're upset too.
You missed some stuff at the top.
Oh.
Please get them. One more. On the left. On the left.
There were some right here, okay, Sydney?
There's someone on top.
Hey, there's something over there on this board.
Jonah, will you come here real quick?
Oh, he actually wants to.
I got it.
Top
Go
right
ahead, you
corner.
got it, all right?
Get it.
You got it, I get it. Everyone good?
Yeah,
We're good.
All right.
No.
So when you create your dragon record,
I wonder what's under the
inside of your memory, depending on how it's laid out and how the hardware does it, will be how many bytes each block takes up, each line. On my machine, apparently it is 4. So, in other words, this line has to be 4 bytes, 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 dot, dot, dot. So if we're trying to get up a dragon, you know, HP would be these 4 bytes, MP would be these 4 bytes, what would we have? Level would be these 4 bytes, and then, oh yeah, the good old TP, these trade points would be these 4 bytes. Now, these are divided into 4 sections, right? 1, that's 2, 3, 4. These are also divided that way, but since it's an integer, it actually takes all those bytes up, right?
So you can put 2 shorts.
You could put 2 shorts in there. But if you have a character, the character would be name. All right, name, but you have to take up the whole block. You can't just allocate the one block. You have to take up the whole block.
Oh.
So now it's allocated as an entire block. The reason for this is for performance, because due to how the buses work inside the machine, it's easier to just transfer one whole block than to try and do it 1 byte at a time.
Yeah.
So that's why when you put in name,
and then when you
went
put
to
in the second character.
when you put in the second character, it's still fine because nickname is right here.
Does it matter how you
You're not on
like
that
how
point.
you put it into the text file?
So yeah, does it matter how you put it in when you're typing it out? For all intents and purposes, no. The compiler, once you turn on optimization, the compiler is going to reorder everything so it makes sense
Okay.
and it works. So you could also do short. I don't know what we're going to have.
Tail length.
And then what should that be?
It should still be 20.
That's right, because tail length is now taking up this.
That both those
It's
spots.
2, yeah.
Oh, okay.
All right.
Did you spell length wrong?
Leng
TH.
th.
There we go.
Okay. Makes sense now?
Yes.
Yes.
Yeah. Sure.
All right, lastly, make sure everyone's paying attention. Size of a dragon is 20 bytes. Bet you never knew that. Size of a dragon.
How many bytes is the size of the dragon?
How many bytes is the size of the dragon? So you asked? All right, what's the size of a dragon pointer?
8.
8.
Nice.
Magic does. Okay.
All right, great discussion. Now, this length right here is dependent on the architecture of your system. On pretty much all x86 machines, if you've heard of that, that's what it's going to be. ARM may be different, or it is different. MIPS, actually I think MIPS sticks with this. But you could have other architectures that may be wider or shorter. And when you take architecture, you'll understand why from a performance standpoint, it's better to do it this way than to try and do it 1 byte at a time. Yes?
So that's why we need to have Linux on our for the class because of the performance itself.
No, sizeof still works in Windows, and the performance is going to, for our program, should be about the same.
Okay, but I could care less about Windows. What about Mac?
Same thing.
Same thing.
These programs, yeah, the operating system, for these programs, the operating system should not slow or speed you up that much significantly. It's really the tools you're using, which really depends what you download. If you actually download a high-performance C compiler, like from Intel, you will see a performance improvement with your code. I think last I checked, they guarantee between 20 and 30% boost if you bought their compiler. It's a pretty big jump.
Is that Moore's law in effect?
No, Moore's law has to deal with transistor density.
Is Moore's law still in effect, or is it?
Yes.
Or did it reach? Because they always predict. When it comes
Moore's
to
law has nothing to do with performance. All Moore's law does is the number of transistors that you can put in an area will double every
13 months.
18 to 24 months. 16 to 24 months, I believe.
I've heard it was. It used to be 18 and it went to 13. Honestly.
What a great law.
If you watch the numbers, it jumps around a lot.
Yeah, I'm not
but
doubting
if you put it on a scale, it's pretty close.
No, I'm not doubting it.
So, I'm just trying to be explicit because Moore's law is abused and misunderstood a lot.
Poor Moore.
Especially Michael Moore.
Like what you did there. Any other questions?
Not right this second.
Not right this second.
Next.
Next. All right. Good. So that's size of. Hopefully I've covered enough of